Hello friends, in this final video we will of computer vision, we will look at image segmentation and depth detection. Let me quickly run the code. Alright, that's it. And the Hugging Face also has a pipeline for video classification. I don't have an example of that, but maybe you can test and let me know in the comments. All right. So the first one is this image segmentation. Now in the object detection we saw the objects detected as these rectangular boxes, right? Now the image segmentation, it won't be like this rectangle, but it will draw the contours just around the objects. Okay, we will see some examples. So yeah, so image segmentation, again, we are just choosing the task. We are leaving it to Hugging Face, to the default model. So again, this is coming from Facebook. It's a ResNet 50 panoptic model. Yep. So there are so many hundreds and thousands of models. It's hard to remember the names of these models. All right. So we have the segmenter. Now we simply call the segmenter with the input, which is image in this case. So similar to object detection, this will return a list and we are printing the length of the list. It has detected 5 segments and next we are printing the segments. Okay, so the 5 segments, so this is the first segment. Again, it will give the label and score, very similar to object detection. The label and the score, it's very confident about this first one. Now then the mask. So for object detection, this would have been the bounding box coordinates, the 4 values, right? Top left and bottom right coordinates. But for image segmentation, this is a contour just around the object, right? So it's hard to define the contour using the few numbers. So what it returns is an image. Okay, so we will plot these images and we'll see how they look like. So that's segment 1 and then another segment, and this one would be the final segment, right? So for each segment we will have the label, the score and the mask, which is actually the segment image. Okay, so let's look at the first one, right? The segment segment 1. One second, image segment. Yeah. So we are just printing the label and the score and the mask, as we saw here, it contains the PIL image, right? So this one will show the image. So this is the first segment. And as you can see, this is one of the cats, right? So in this image, it's one of these cats. Maybe let's look at here. So the first segment is this cat and the model has drawn the boundary in the form of this segment very, very accurately, right? Yep. So here is the ears, the legs, maybe the tail, everything, right? And the second segment, it's a remote and again very high confidence score. As we saw here, we have a remote here. We have a remote here. Now, I'm not showing you the remaining 3 segments, but I looked at them. It has detected all the 5 segments so accurately with very precise boundaries. Okay, that's quite nice, right? So that's the first task, image segmentation. And the final task is depth estimator. So given an image, it will find out the depth in meters for each pixel of the image. Okay, it will be clear when we see the image. So again, we are choosing the task depth estimation, leaving it to the default model. Interesting. This time, this model is coming from Intel. Okay. So yeah, let's just call the model with the image. So the result, it has an attribute called depth, which is again this PIL image, similar to the mask we saw here. Okay. All right. So let's try to understand what's happening here. Now let's look at the original image. Now from the image, it is clear the photograph is probably taken more from the right, right? So to the photographer, the cat on the right is more closer as compared to this cat on the left, right? So the depth detection, what it does is it show the depth in meters for each pixel on this image. So if something is closer to the photographer, meaning the depth is low, right? That will be displayed as a white in the white, right? It's a gray image. It's the output is going to be gray. White means that's closer to the photographer. And if something is displayed in dark, that means it is very far away or the depth is very high. Okay. So for the cat image, the more whitish thing is here, right? So the depth of the image here is low and the depth is very high in this location. Now I'll have another image which makes it much more clear. I'll show you in a second, right? For the parrots, again, the two parrots are on the foreground and the background is blurred. Uh, so again, the depth is very low in these parts of the region and high in the background. Now we can access the depth values also in meters. We will see in a second. Now I have taken this image for easy demonstration purpose. So it's coming from Medium. So this image we can see it's taken. We can easily see where the image is taken from, right? So if you look at the depth, for example, this object depth is low, whereas this object depth is high. This one is even higher. This one is even higher. This one is even higher, right? So for this image, if we look at the depth, so this is how it looks like, right? So this part of the image, this part of the image, these ones are closer to the photographer and the depth is also very low, right? For this part, and this part. This is the sky. It's too far. So the depth must be very, very high, really high, right? So that's this part. Okay. So this part. So as we move from this point to this point, the depth is increasing. So it's probably increasing by a couple of 100 meters, right? So that's what you see here. So here the depth is low, and as we go on this road, the depth is increasing. Okay. So let's look at this result object. All right. So it has this depth variable, which is the PIL image. But here we have this tensor, which shows us the depth in meters for each pixel, right? So if this image is, let's say, 240 by 240 dimension, now this one would also be the same dimension, and each pixel uh, uh, or each value from this tensor represent the depth in meters for each pixel of this image. This is quite amazing, right? I mean, the depth classifying image is one thing, but predicting or determining the depth for each pixel is a completely another thing. So there is probably a lot of physics, optics, etc. involved in calculating these depths. All right. So we have covered six major or six important tasks in computer vision, the image classification and the zero shot version, object detection, the zero shot version, the image segmentation, and finally the depth detection. So with this, we covered all six tasks in the computer vision space. And next, we will look at some tasks in the audio, and then finally we will look at some multimodal ones. Thank you.